What came first, the speed of light, or the meter you used to talk about distance? In the energy filament theory, C is a physical property of an energy C, while meters and seconds are bookkeeping labels built from local matter. So locking them together can hide real evolution behind perfect consistency. Most people imagine this story: the universe hands us a fixed C, then humans build rulers, measure it, and discover the numbers. Reality is closer to the opposite. For most of history, we started with whatever length and time standards we could manufacture, and C was a measured quantity inside those imperfect standards. Early meters leaned on Earth, metal bars, and later a chosen wavelength of light. Early seconds leaned on Earth's rotation, then later atomic oscillations. Units came first, then C was something you went out and measured, with error bars and arguments. That was healthy science. Then in 1983, the system made a radical move. Instead of treating C as something we measured, the meter was redefined in terms of C, and the value of C in vacuum was set as an exact constant. After that, C stopped being a number you went hunting for. It became part of the definition of the yardstick itself. So when you hear about precision speed of light experiments today, it helps to pause. Many such tests are really checking the self-consistency of a local triangle, how the second is realized, how length is realized, and how electromagnetic propagation is tracked. That matters a lot, but it is not identical to directly interrogating the universe's deepest propagation capacity across all conditions and all cosmic history. You can picture the logic with a simple analogy. If you define one lap as whatever distance the runner covers in 10 seconds, and you also define 10 seconds by your own watch, you can always report the runner's speed as exactly one lap per 10 seconds. The stability is partly built into the definition. It does not prove the runner could not run differently on a different surface, in different winds, or with a different body. This is where this picture draws a sharp line. A meter and a second are human labels anchored to local physical processes, atomic clocks, material stability, instrument calibration. Those processes can be extremely stable locally. They can also be environment sensitive in principle, because matter lives inside an environment. Even mainstream physics already accepts that clocks tick differently in different gravitational potentials. The second is not a mystical brick floating above reality. It is a physical rhythm produced by matter under conditions. In this view, the deeper condition is the tension state of the energy C. Now the cleaning question becomes unavoidable. If the underlying medium's tension and texture can drift over cosmic time, and if matter's internal rhythms and material lengths stabilize inside that same medium, is it guaranteed that the deeper propagation capacity is eternally identical everywhere? Or is it possible that multiple pieces co-evolve, so your local measurements keep producing the same ratio even while the underlying relay ability slowly changes? Here's the strange part. Once you define the meter using C, you lose an independent ruler for detecting whether C might vary with environment. Any real variation must show up somewhere else, like in how the second is realized, how matter stabilizes length, or in calibration layers you rarely think about. The system stays self-consistent, but self-consistency can hide which physical knob is turning. And if the universe is a medium physics matters. Waves travel differently in water with different tensions and densities. If the cosmic C has slow drift or regional variation, then treating C as an environmental probe would help you see the C. If you declare C untouchable by definition, you are pushed to insist light is always the same speed everywhere, and any difference must be absorbed by the ruler and clock instead, whether you notice it or not. The punchline is simple. Since 1983, C is constant is partly a definition, not only an observation. It tells you local physics is beautifully coherent in a given time slice, but it does not automatically slam the door on slow evolution of the underlying propagation capacity across cosmic history. Tap follow, share it on New Physics, Clear Universe.